Calculus 1 students. We are in the section of limits at infinity, and this is a problem that came in the final exam of fall 2018. Find the horizontal and vertical asymptotes of this function. Okay, this is not a hard problem at all. The only thing that can throw you off balance is the exponential functions, the fact that we're playing with e to the x instead of simple rational functions. And the asymptotes will look a little bit different, actually. All right, but the procedure is the same regardless of the function we're playing with. So, all right, we're going to begin with the vertical asymptotes. So that will be step number 1. And the horizontal asymptote will be step number 2. Okay. So a couple of reminders. For the vertical asymptotes, so what we call VA, right? We abbreviate. What you do is you look for the values for which the denominator is equal to 0. And after that, you just look at the limit and do a direct substitution and see if you can conclude anything from there. So, okay, find values of x for which the denominator is equal to 0, and we don't actually need to compute the entire limit. Actually, we will see where to stop. But just so that you don't forget to do it, compute the limit as x is approaching these values. Okay. So, okay. First of all, it means that we need to solve this equation, right? That's easy to do. So first step is to send the 1 on the other side. Then if you remember, there's more than one way to get the value of x here, but a way that I strongly suggest is just to think about taking the logarithms on both sides. I don't really need to do that myself because I know that x is 0 just by the definition of a logarithm. The value of the exponent that makes e to the x equals 1 is by definition the logarithm of 1 at base e, which is 0. But anyways, okay, let's put the logarithms there. Let's use the rules of logarithms. So we have x ln of e is equal to ln of 1, which we know is 0. So in other words, we found out that x is equal to 0. I kind of wish I spread the problem a little bit, but it's okay. We're going to finish there. A big mistake would be to stop there and just say that x equals 0 is a vertical asymptote. It could be, but it could also not be. Okay? How do we know? Is by actually writing the limit. Then, so actually I will put a capital here, let's say. Then we just write the limit as x is approaching 0 of f of x, which is the same as the limit as x is approaching 0 of 2e to the x minus 5 over e to the x minus 1. And then we use direct substitution. Direct substitution here gives us 2 times, well, actually, let's do it straight. We have e to the 0, which is 1, so that's going to give us negative 3. And we already know that the denominator is going to give 0, but hey, e to the 0 is 1, 1 minus 1, 0. Okay? If you have negative 3 over 0, this is enough to conclude that you have vertical asymptote. You don't need to continue calculating the limit. That's the point. Okay? So, which is enough. Or actually, I will just put, oh, yeah, I have a better idea. I'll put the negative 3 over 0 here, so that gives me more space. and I will just say this is enough to conclude that x equals 0 is a vertical asymptote. Okay. So we finished the first part. Okay. So actually, I have an idea. Again, I will just put the vertical asymptote here. And this will be our final answer. So let's actually put green. Okay. So we know that it has a single vertical asymptote. We know that the vertical asymptote is x equal 0. Okay. I will erase everything except this little box. And we will go for the horizontal asymptote, step number 2. Okay. Remember, to find horizontal asymptote, you need to compute the two limits at infinity. So we compute limit as x is approaching infinity of f of x, and the limit as x is approaching negative infinity of f of x. All right, so the limit as x is approaching infinity of f of x will be 2e to the x minus 5 over e to the x minus 1. Okay, so if we try direct substitution, what we will get is we will get infinity at the top and infinity at the bottom, okay? So this doesn't tell us anything, so we need to factor what's large. So in this context, obviously what's large is the e to the x. So let's factor it out. So we have e to the x times 2 minus 5. And here, a little trick that I can give you is to use the rules of exponents to your advantage. So after you factor out e to the x, you will have e to the 0 minus, minus x, so e to the negative x. Whew! That was hard to say. Same thing at the bottom, right? So you have to factor the e to the x here, and you will have 1 minus 1 times e to the negative x. Okay, before we directly substitute, let's just cancel the e to the x, or cancel is a bad word. Let's just say simplify. So after simplification, what's left is only this function. And then by direct substitution, this turns into 2 minus 0 over 1 minus 0. So in other words, just 2 over 1. So actually, I will skip that step. There you go. So 2. Okay. As a result, we know that x equals 2 is y equals 2. Whew, what am I saying? Y equals 2 is a horizontal asymptote. So let's add it over here. However, be careful because we are not done, right? We need to also compute the limit as x is approaching negative infinity of f of x, which is the limit as x is approaching negative infinity of this function And we're lucky because here direct substitution is actually working. What we have is 2 times 0 minus 5 over 0 minus 1. So here what you have to remember is how do direct substitution operate inside exponentials that are for which the exponent is either going to infinity or to negative infinity. Okay, and this is detailed in the lecture notes. You have to get used to it. But as the exponent is going to negative infinity, the base is bigger than 1, so it's gonna decrease to 0. That's how you do this kind of thing. Okay, and as you can see, the result is 5. So you have another horizontal asymptote. So I'm gonna write it here. Y equals 5 is also a horizontal asymptote. So you have to add it over here. So and y equals 5. There you go. As I said, simple problem. The only thing is that it's not simple rational functions. You have exponentials in it. So you have to be slightly careful, but as long as you are, this is a good win. All right. See you in the next video.